Welcome back to Little Guys, the show about little computers that are doing their best. And today I've got one where I actually know what it was trying to do its best at. I was told that this actually came out of a Coinstar machine, and that's all I know. It didn't come with a hard drive. I haven't seen any of the software. I'm just told that it got dropped off by somebody who said that it was being used in a Coinstar machine. So I can't tell you what specifically any of the ports on here or anything would have been used for, or what made this machine well suited for that, other than the fact that this is apparently what you'd find inside a Coinstar. At least one generation of it. I'm sure they've made multiple different types of machines. And naturally, just like the other machines in this series, this one is definitely a personal computer. It has a Core i3 apparently. It's got a license for Windows Embedded. I think this COA puts it in the Windows 7 era. Now, unlike several of the other machines in this series, this one actually says how much current it uses. It's rated at 12 volts and 5 amps. And it does have a manufacturer, and it has a model number, and actually it's got a remarkably professional-looking bevy of certifications on here. This thing's UL listed. I didn't actually notice that until now. Now, presumably, Premio is not whoever actually makes the Coinstar machines, but just whoever makes this system itself, and then Coinstar, the company, would have bought them and made whatever modifications they needed and loaded up the software and all that. Let's see if we can figure out how this thing was sold. Okay, here we go. Premio has it listed on their website as KCO 3000 CFL industrial computer with 3U certification. Oh, that is not the same computer at all. I probably should have checked before I read that. Yeah, it probably isn't on their website anymore. Of course, it's also possible that this particular model was not sold to the general public. Maybe this was made on spec for Coinstar. I mean, COS? Coinstar? Probably not. Yeah, the RCO 3000 looks kind of similar. Like, it's definitely got the same chassis. I recognize the heatsink sort of wings here, but obviously the machine inside is completely different. But I mean, that's going to be pretty much a given with any of these companies. You know, this particular model may have been produced exclusively for Coinstar, for all we know, or it may have been one of dozens being simultaneously sold. To the point where they didn't even bother listing them all on their website. Maybe you needed to get like a PDF emailed to you to actually see what their entire product catalog was. Who knows? Who knows? I have no idea. But we can at least take a look at it and see what's obvious. So what do we have here? Well, we've got the DC input, as is common on these things. It doesn't take, 110 volts directly, and it doesn't take any sort of like laptop power supply or anything. It takes one of these, which I've been reminded is often called a Phoenix connector. Now, I'm certain they're not the only company that makes them, but they may very well have been the company that originated them. And they show up on an awful lot of these machines. In browsing ones I could find on eBay, I see connectors very much like this all over the place. And of course, it's not a connector, right? It's an entire family of connectors. This is, a 3-pin of a particular pitch, and then they've got, 4 pins and probably 12 pins, and they probably have some with a different sort of keying on them, and some with screws, some without. So the actual name for it is probably something like, PS-1065-3M. Right? But anyway, this is the connector that takes. This came with a power supply. I don't know if this is the stock supply. I don't know if this company would have provided one, or if they expected the end user, or that is to say, the system builder that was going to put this into something to manufacture it themselves. It could really go either way, because for this kind of product, they would not have gone out of their way to get a custom power supply made like Dell or somebody would. So this is just an FSP group, which is an extremely common kind of power supply, especially in 12 volts. I think I have about 15 of these for different products, all with different ends on them. And my guess is that this probably came originally with an end of some kind on it, and whoever assembled this just hacked the end off. But they did a good professional job of it. This is about the cleanest job you could do of that sort of thing, because this type of connector, this is a screw connector. So you just get it by itself, and then you insert wires into it. And those wires could be anything, solid core copper wire, they can be stranded wire. But in this case, whoever put this together not only bothered to put some heat shrink over this here in order to sort of strain relieve these so it doesn't start to tear the outer sheathing further back as the wires separate. But they've also put ferrules on here. And I don't think this is condescending to explain, so forgive me, but I feel like probably very few people know what a ferrule is, and they're very, very cool, so I'm going to tell you. I never saw one of these till I got a job at an amplifier factory in my late teens, but the basic idea is the wire under here is stranded wire. So if you put it into a connector like this and run the screw down, it flattens, the strands flatten, and they can snap off, or they can get pushed out of the connector, or they can fray. So you put one of these on here, and it's just like the ferrule on the end of a shoelace. It's basically a tube that's crimped onto the wire to keep the strands from unraveling. So in this case, it's metal rather than plastic, but it does have this little plastic sheath on here that also serves to keep the wires from fraying. And there's nothing all that special about them other than the fact that they're just a little bit of extra polish when you're doing something like this, like a connector that's not going to have an overmold on it to hide whatever sins are underneath. If you're hand assembling a connector, you really do yourself a service to put ferrules on the wires. There's no reason not to. Every hobbyist could do it. I don't know anybody who does, but you could just buy them and put them on, and it really improves the quality of the connection. Just a little bit of a PSA there. I mean, when you shove these in here, it feels like you're plugging in an actual connector, even though it's just a bit of metal. And when you screw them down, it's very positive. It's not like stranded wire where you can feel it compressing. Nah, once that's down, that's down. Now, speaking of screwing, this connector can also be screwed into the machine itself. Now that this is all screwed together, if this is in like a high vibration environment, like a train or something like that, or, a machine that people are shaking, they're pouring coins into it and going like this, and there's all this rattling going on, then your connector isn't gonna work its way out over time, right? So that's a pretty good idea, and it actually makes me really mad that most connectors on computers don't have screws anymore. They used to, back in the days where D-sub was what everything used. Every single connector on the back of your computer could be screwed down, and then nothing would come out until you wanted it to. Of course, there were downsides to that as well, as anybody who's tried to unplug a DisplayPort cable without thinking has learned. Now, besides the power connector, we also have VGA, which is, of course, the lingua franca of these little boxes. No DVI, no HDMI, no DisplayPort, because you don't need them. No one's going to miss them, and you can't rely on anything having them. But every piece of industrial equipment is going to have a VGA port. It will never die. Then we have a speaker output, which I imagine was used heavily in this application, and a mic input, which I imagine wasn't used at all. At least one hopes not. Now, the USB ports are an interesting topic to me, and I'm going to go into some utterly baseless speculation here because I have no idea how to look this up, but there's USB 3 super speed ports on here, and that makes sense. I can't remember what generation this processor is, but I think it's from sometime in the 2010s when USB 3 had become standard. Several of my other little guys don't have any USB 3 because they're from the late 2000s and early 2010s when it just wasn't an assumption yet. So this is not surprising for this era, but I wonder how many of these things are still being made that only have USB 2. I would be really curious to know if they're still making devices like this that have like a Core i3 12th gen and then like 16 USB 2 ports and no USB 3. Because, it does cost a little bit more to put in there, more expensive connectors, and I think you have to pay a licensing fee, right? So you could chop a couple bucks off of something you're making in huge quantity that way. And speaking of terribly outdated things, I have no idea if this is gigabit. It probably is given the era, but like I've said before, I have seen devices from well into the 2010s that had 10100 Ethernet. Then we've got the remote switch. Now, as far as I can tell in the lingo of this industry, instead of saying power switch, they just say switch. I don't know why. Must have just caught on. And then we've got remote reset as well. So you can have buttons that are very far away from this thing that can be used to reset or power it on and off. Or, as I have been told several times by people in comments, these could be connected to other systems, stuff that can, watchdog, that's like a process controller or something like that. I guess if it's not getting a response from the machine, it can power cycle it, or it can turn it on and off as needed. I don't know, but yeah, those are used for many different things. And speaking of which, you thought there'd be more front panel connectors, but instead, it was Dio. This is the digital I/O port. I mentioned this in the first video, and I still don't know any more about it than I do now. My understanding is that it's basically GPIO like you'd have on a Raspberry Pi, where you can sense a single value on each one of these pins, just like an on or off value, except that instead of going straight into a chip, it's going into an opto isolator, which means that you can send it voltage and it'll detect it, but if you send it way too much voltage, it's not going to get deeper into the circuitry and fry it, because it's just going into an LED, which is illuminating a photodiode. So you can fry the LED if you send it like 120 volts, but it's not going to damage anything else inside the machine unless you really juice it. I mean, if you put 2 kilovolts in there, I'm sure it's going to cook something, but the worst that it should happen if you put like 48 in there by accident is it should just blow out that pin, but not fry the rest of the system. And finally, we've got our 4 serial ports. As the label suggests, these are not Ethernet. This is a standard, if you're not aware, in all kinds of industrial and commercial gear. RS-232 used to universally use a D-sub connector, but those just took up a little bit too much space, and I think they cost too much to manufacture. So most companies switched a long time ago to using RJ45 connectors. They take up less space, you can use cheaper cables, although there are still a lot of these machines being made that have ordinary D-sub connectors on them, and I would guess that a lot of the reason for that is, again, the jack screws. It's the fact that you can screw them in and then they don't come out under vibration, under, getting tripped over, etc. And for a mission critical application, relying on a little plastic tab to keep your communications intact is no bueno. As for why we have 4 serial ports, just in case you're not aware, RS-232, one of the oldest digital communication standards in existence, I think it goes back to the 60s formally, but more or less goes back even further, is still being used because it is the lowest common denominator of communication between computers. It's just a byte pipe. You could plug it into any 2 devices. They'll always understand each other. However, a lot of these devices speak not just RS-232, but also RS-422 and RS-485. So technically, I can't be sure that these are RS-232. But usually when I see those other protocols, they're labeled as such. The fact these just say COM 1, 2, 3, 4, they're probably 232. All right, so that was an awful lot of talking, but that is everything that's on here. Oh, other than we have a power switch, and then it looks like there's a reset pinhole there. I didn't notice that until now. Do I have a pokey stick? Let's try this rusty proboscis. Oh, there's a tactile switch in there, but it is just loaded. That has a really heavy spring in it. Well, I guess they want you to be sure. So, lacking any kind of spec sheet or marketing for this thing, the only way you can find out what's in it is to just open it up. So, let's get to it. Now, as is often the case with these things, taking the screws out doesn't immediately make the case come off because, once again, this is a passively cooled machine. So, there we go. You got to break it loose from the thermal pad. And you know what? I've just noticed this. Once again, we've got bleed. That thermal pad is leaking. And once again, we have an extremely robust case. This thing is absolutely rock solid. What is that? That is about 1/8 of an inch thick. Actually, it's a little thicker at the thicker parts. Let's get the definitely not counterfeit Mitutoyos. So we're looking at 6.65 millimeters there and about half that over here, although it gets thicker further in. So yeah, big piece of metal. Couple things I'd like to comment on here that I think are neat. Not knowing anything about manufacturing this sort of thing, I should point out, but I think I can see why these were done. The screw holes are not machined into the aluminum itself. They have actually put in steel inserts. It's sort of like they've helicoiled this from the factory. I can see exactly why they did that, right? It just gives you better threads. But I didn't really know it was a thing. Also, I'm really curious what these depressions were intended for. They're not used by this thing in any way. Presumably this was made once and then used by just 50 or 100 different sheet steel modules that go in there, right? When you're making like medium and small yield parts out of aluminum extrusions and machined parts and whatnot, you want to try and hit as many bases as possible. So even if something that you're making today doesn't necessarily use all the features in here, you want to have them all there. So I don't know why these dips are here, but something wants them. Anyway, let's set that aside and look at the machine itself. So there's definitely some nice compactness going on here. We've got the CPU under here. I will take that sync off and show it to you shortly. It does have a CR2032, not some proprietary cell. Thank you. We've got a single stick of RAM, which is actually, and I don't know that I've seen this before. Maybe it's common, I just never noticed, but the slot is actually labeled. It says 1.5 volt DDR3 standard. Terrific. As I think I mentioned before in a previous episode, the term AT versus ATX in the context of these devices is shorthand for whether the machine turns on instantly as soon as power is applied or whether it waits for you to press the power button. And of course, that clearly stems from the distinction that used to exist between AT and ATX power supplies. But in this case, it's meaningless. There's no AT or ATX going on here at all, right? It's a bespoke voltage regulator system. But nonetheless, they still have a switch here for it. I guess the terminology just stuck because that's your AT mode, that's your ATX mode, and it just determines whether you need to press the power button to turn it on. And of course, like usual, these things are full of options, right? So right off the bat, we can see you could have gotten it with DVI. After all my big talk earlier about everybody only using VGA. Hey, look, I was joshing. It's an option. Also, you could have gotten it with 2 network interfaces. So I'm pretty sure there would have been another NIC chip populated right there. But my favorite option on this thing, and on any of these to date, really, is the hard drives. Because this obviously has a bay for 1 SATA drive. But they apparently could have populated it with another SATA connector here, but where would the drive have gone? And then another one here, but there are 3 completely different patterns. I'll show you more of that when I take the motherboard out. Oh, and here's a fun thing. Instead of a jumper or a button, the clear CMOS is a switch. So you could just leave the CMOS in clear. That must have just been a cheap part. I don't know why you'd want to leave that on. Anyway, let's get this hard drive carrier out of here so we can start taking this thing apart. With that out of the way, we can see a FinTech chip under here, and I keep seeing these on all these devices. They're always Super I/O chips, and this one probably is as well. And it makes me wonder if they're just like the only company making Super I/O chips. That is a F81866AD. Oh, interesting. FinTech, aka Feature Integration Technology Inc., apparently markets this chip specifically for industrial PCs. Maybe that's why I keep seeing it, because it's actually like purpose designed. As with most Super I/O chips, this does a whole bunch of things. It's a parallel port controller. It's got 6 serial ports built in. Ooh, that's spicy. It's got SIR. Maybe that's serial infrared. I'm just going to guess. A CPI management function and a floppy disk controller. Is SIR serial infrared? I'll bet it is. Actually, Hewlett-Packard is saying that it's also known as slow IR. So named because the 115 kilobits is the same rate as the fastest regular serial cable. Huh, okay. Oh, and this does all sorts of other fancy stuff. It's a keyboard and mouse controller. It's got a bunch of voltage sensors. It's got fan controllers, temperature sensor inputs. And then it also supports, look at that, 72 GPIO pins. So I'm guessing that DIO interface backs up onto this thing. I had been wondering what they were using for that. Man, I wonder how easy these are to interface with. Those might be really interesting parts for a hobbyist who wants to make a GPIO board for a normal modern PC. That's not my line, but it might be yours. All right, well, that's a really neat device. Let's see what else we have in here. So on top here, we've just got a Realtek chip. That's going to be your network interface. Then we've got a dual audio amplifier over here for your speaker output. And that's pretty much everything of note on top. So I'm going to take this heatsink off. Although, again, it is not a heatsink. Its only function is to get heat from the processor up to the top of the chassis. I have no idea if there's a proper term for these. I've just been calling them heat blocks, heat shafts, whatever comes to mind. Oh, and I forgot to take the RAM out, but that is, I think, 2 gigs of DDR3. Nothing too spicy, and there's nothing to note underneath it. Now, when I first took this sync off, it was stuck on pretty good. You can see it's wiggling loosely now, but originally it had some very unfortunate thermal compound on there. I'll just show you a clip of me flaking all that awful stuff off, because I know you want to see that. Yeah, it was gross. Oh, now here's another thing I wanted to comment on, and I guess I have my answer already. I was noticing from the top that they've got these steel inserts pressed into the aluminum, and I was thinking, like, why? Why do you need those? Like, aluminum can hold a screw head. It's not like there's threads in the block itself. What's the point? There's the point. It's because these are little risers that lift it up off the surface. And since this is an extruded part, this has probably had no machining work done on it at all. If you wanted to machine that in, you would have had to take the extrusion, thicker than this is, put it on a machine, and then mill all this surface down. It would have been very time consuming. Whereas here, they've just pressed these steel inserts in here, and that just lifts it up off the board exactly the right amount. Although what's interesting to me is that these are exactly the right height, right? Because this thing needs to sit directly on top of the cores there. There's no shim, there's nothing to give it any springiness. So these are exactly the right thickness. And I wonder what the tolerance on that is. Anyway, there's the chip itself. It's got the 2 dies, which I think tells you that it's one of the later models. I don't think they used to do that even on the cores, but maybe I'm wrong. I don't know. I never checked. And I don't know if that's the CPU and then the GPU, or if it's not quite that clean cut. I don't know anything. Oh, okay. Yeah, the first response for Googling this is people saying it's not the GPU. And apparently it's the PCH, the Platform Controller Hub. Ostensibly, the CPU and GPU are both on one die, and then that's the PCH. The more I know. But anyway, let's finish getting the board out of here, because there's a couple more things to show you. All right, so that's all the screws out, but a fun thing about this design is you still can't take it out because all these connectors down here are on a daughter board, which is riding below the motherboard, and stuck on with a little sandwich of standoffs, if you can see that in there. They've got a smooth one and then a brass one, like they couldn't get all the same parts. But to get that out, you have to actually take the back panel off. So there we go. Now it comes loose. So there's not a lot going on down here other than power control circuitry, but there are these 4 chips that are right next to the serial ports, so I'm going to assume that they're line drivers, level shifters, something like that. Oh, what a number. SIPX SP3243EUEA. EIEIO, more like. Huh, okay. I had assumed that the function of this thing was to convert from the onboard voltage, like 3.3 or 5 volts, up to the higher voltages required by RS-232, which is like 10, 12, something like that. But no, this says that it produces plus minus 5.5 volts. Huh, I guess plus minus 5 is quite common. I have no idea how I never learned this. It seems like it must be quite obvious. Well, anyway... But anyway, that's the only interesting thing going on back there. There's nothing else on this board, even if you take it off, it's a pain in the ass, so I'm not gonna. But I did tell you that I was going to show you this. The SATA connector for the one hard drive caddy we have is clearly totally different from this one, and of course totally different from this one. Obviously, this would have been an individual data connector and power connector. Probably one of those 4-pin Berg connectors they use for floppy drives, whereas this one is obviously a single piece like this. But given that it's so different, it makes me think that it might have been an upright one. So I wonder if they were anticipating that you would plug like a disc-on module into that, or what? Because there's nowhere on here they could have put another hard drive tray. But what is interesting, if we put this tray back on here, we see the screw holes are there, and there. And then these ones are for the drive itself. And then for some reason, there's a hole here. I'm not really sure why there's a hole there, actually. But what's this? What's this standoff here do? I have no idea. Is it just to support the caddy? Probably not. This is a pretty heavy piece of steel, so I have no idea what that's for. I also have no idea why there's an absolutely enormous via here or there that look like they were probably intended to receive standoffs just like that. They must have been for other options, so there's no way to know what they could have been. And there's exactly one other thing on here that's interesting. There is a connector here with a curiously small pitch labeled debug. And presumably it's way too many pins to be serial, so I'm wondering if that's a JTAG port or who knows what. And then of course there's just a generic jumper block next to it, and who knows what that is either. But anyway, that's all I have to say about what's inside this thing. So I'm going to go ahead and goop up this processor, and I'm going to do the deeply sacrilegious thing of putting Arctic Silver 5 on this industrial computer. I need to order like a great big monstrous tube of just generic thermal compound, but all I have right now is this gamer shit. So I'm going to put that conductive grease on here. That'll ensure the reliability of my industrial machine. Ooh, yeah, I just got it everywhere. Ooh, terrific. Maybe we'll fry this thing. By the way, I'm making no effort to apply this cleanly because I watched Gamers Nexus's video about testing various application methods, and as far as I could tell, it looks like it just doesn't matter what you do, so I don't care anymore. Oh, but you know what? I just realized the CPU heatsink standoffs are in here. On some boards, they're actually pressed into the board or otherwise affixed to it. Because those standoffs are on the chassis and not on the board, it's a good idea to put these screws in first, because imagine how much it would suck if you put all the other ones in and then the board was located just a little bit off, and when you put the CPU heatsink on, strange things happened. As with many of these machines, I have no idea how much torque to put on these screws. Like, there's no shim, there's no buffer in there. And this style of sink attachment has not been used on consumer machines for decades. Like, even laptops have heat sinks that are held on with screws that have springs on them, right? And when you bottom them out, they usually just stop dead. But these ones, yeah, you can put some torque on them, and you can feel the threads compressing. So yeah, I don't know. If I were to just reef on these, would I just crack the cores? Probably. It's supposed to be getting done by somebody over at Premio who has, an assembly line torque screwdriver. Oh, and we'll need a hard drive, won't we? Let's go with this nice Intel SSD. Wait, DC? I don't know what that means. Is that data center, I wonder? I've seen lots of Intel SSD 320s, but I don't think DC. Ah, yeah, that's the data center series, apparently. Cool. All right, case goes on. All right, let's get this thing fired up. Oh, it must be in AT mode. Hey, bud, we're not ready for you yet. All right, let's try it now. There is actually a little secret power light hidden down there, I think. Oh, yeah, there it is. Oh, okay, there's actually several diagnostic lights under there. We've got power, disk, and then WDT and GPIO. WDT? Oh, you know what? That's probably short for watchdog timer. If you're not familiar with the concept, that is basically a hardware mechanism in a lot of industrial computers and microcontrollers and things of that nature, stuff that's supposed to run unattended for very long periods, often in mission critical applications. Basically where if the machine hangs, if it falls over for some reason, it can't just sit there and wait for somebody to find out that that's happened and come along and do something about it. So it basically needs to be able to detect that something has hung the whole system, and without knowing why that is, take care of the problem the same way we would. Just reboot the damn thing. Don't quote me on this part, but I think usually what happens is you've got like an interrupt, like a software interrupt or something like that software running on the machine can strobe periodically, and the WDT watches that, and if it sees it stop strobing for a certain length of time, it assumes the machine is hung, and it just power cycles it. I'm curious whether we'll find a setting in here about that. And of course, the GPIO light, I'm guessing, is an activity light that triggers every time something gets written to the DIO port. But anyway, it appears I did not crack the core, so the machine's running. We have a Broadwell ULT Core i3 5010U. I do not know what Broadwell or ULT means. Okay, apparently Broadwell is the 14 nanometer shrink of Haswell. I had no idea. I've never heard of that name before. But what does ULT stand for? I know about ULV processors, that's ultra low voltage, but what's the T? Ah, there it is, ultra low TDP. So this is specifically a chip intended to put out very little heat, which, yeah, that makes sense for a machine with passive cooling. And per Intel Arc, we've got 2 cores, 4 threads, so it is doing hyper-threading. It outputs 15 watts TDP, so this is no Atom. And yes, this did indeed launch in Q1 2015. And otherwise, it's a pretty normal desktop processor, 16 gigs of memory. You're going to have a whole bunch of PCIe lanes, yada, yada, yada. Socket supported FCBGA 1168. And does it support LMNOP too? All right, anyway, let's peek through the BIOS here, see if there's anything fun and interesting. They've answered several of my questions. The system manufacturer is Premio Inc., but the board manufacturer is C&T Solution. Nonetheless, the model number for the board itself is COS3000, so this board was custom made for this machine, which is not surprising. Is C&T Solution the same company as Premio Inc.? Don't think so. We are a global solutions provider of industrial-grade computers and embedded systems. We design, manufacture, and deliver computers from embedded IoT rugged edge systems, yada, yada, yada. And those definitely look similar to the machines we have here. This is incredibly vague. From the website itself, they could be anyone from like an MSP or like a value-added reseller or, you know, a chassis manufacturer or anyone in the world. I have no idea what role they actually played here. Like, this says they made the board, but kind of doubting that. I feel like the website would be more clear about that. Watchdog function enabled. Oh, there we go. You can set it to either seconds or minutes and tell it how long you want it to wait. It doesn't say, of course, here what you need to do to keep that watchdog from tripping. Maybe that's documented somewhere else. And once again, like we saw in another machine, this actually lists which Super I/O chip it has. Is that relevant information to somebody who's just looking in the BIOS config? That seems so weird. Ah, here we go. This is what I expect from a machine like this. SATA controller enabled. 1 port. Which is actually really funny because we saw 2 other potential ports in there. So do they put a different chip in there or configure the existing chip differently? Or do they only ever populate one of those SATA port patterns depending on what's being deployed? Maybe this doesn't support multiple drives and that's why there's only room for 1 caddy. That would actually make an awful lot of sense. Could also be they just customized the BIOS though. Oh, that's weird. I've never seen this before. You can tell it whether the connected drive is a spinning disk or an SSD. Why? What would the BIOS need with a Starship? I'm finding people on forums saying they have also never figured out what this means. This person says they looked in the datasheet for their chipset and there were no settings related to this. Oh, no, here we go. Oh, it's a thermal thing. Intel PCH BIOS spec. Thermal throttling. When set to SSD, the BIOS will set thermal throttle control port inactive and dispatch. We don't have more information as what it'll affect. Okay. This offers better compatibility for SSD. Some SSD models does require the change of SSD. Set it. Don't not set it. We don't know what it'll do, but you'll regret not setting it, bud. Okay, so to protect SSDs from poor data retention caused by overheating, the thermal throttling mechanism is implemented in the controller. When the chip reaches 70 degrees Celsius, the SSD will activate its thermal throttling mechanism, which lowers performance to let the chips cool off. Huh. I guess that's a cool feature and I should turn it on. I have never seen that before. It was probably in several computers I had, I just didn't see it. The full screen logo show is disabled. I'm going to turn it on, see if this thing actually has a logo. Big money, no whammies. It does! C&T Solution. I won! I've discovered their secrets. All right, I'm going to go dredge up Windows Embedded so we can get this thing set up right. BRB. All right, so I have obtained Windows Embedded. Now, I have read that there was actually a Windows 8 Embedded, which I did not know, but I saw one website that said that 7 remained the standard up until 2020, and that was not a Microsoft opinion, so yeah, I don't know, but it's probably 7. Now, this does want a CD key, apparently, from what people have said, and I don't know if this thing back here is a CD key. I doubt that it is. It doesn't look like one. That's not the installer I expected. That pitched right into WinPE. Build an image, deploy an answer file. I don't know what to do here. I've never done this before. Let's try deploying a WIM. Oh, here we go. Install.wim. Is that going to do it? It's 283 megs. That might do it. Let's try that. I wonder actually if it's going to work correctly, given that I haven't partitioned the drive or anything, but let's just see what happens. Whoa! I've never seen anything like this. I've never messed with Windows Embedded before, only on machines that came with it. So we have to choose a template, and this is a raw Microsoft image, and it comes with a template for digital signage. Also, industrial automation, minimum config, set-top box, thin client, or application compatibility. Oh, okay. It's basically just selecting which components are going to be enabled or disabled. This is basically what makes Windows Embedded. It's the same as normal Windows, except that you could choose not to install certain bits and pieces. Oh, I guess we're actually going to build an image. I don't know if this is actually going to install it. So you have to choose which drivers you want embedded ahead of time. Let's see what happens. Okay, so it's got a few things, but it's definitely missing some stuff. That's not surprising. All right, here we go. And this is where we get to choose what we want to install. So I could try and make just like Windows 7. Sure, why not? Let's do it. This says that's going to take up 4 gigabytes. Oh, I can't click next. What is it upset about? Ah, there's some dependencies. Ah, okay. For each of these features, you could pick only one of them. So I uncheck unbranded, and we get the default Windows embedded. And then I have to uncheck command prompt shell, and I'll get the full Windows Explorer shell, and so on and so forth. There we go. I got it. Okay, I thought it was maybe just going to build an image, which I would then have to install separately, but it looks like it's going to just install the OS. I was terrified, but I think I nailed it. I guess we'll see if it boots in, well, quite some time, because this is going to install at normal, like, CD-ROM speeds. All right, that took like a solid 15, 20 minutes. That was a lot slower than I expected. All right, it wants a product key, and yeah, that definitely does not match what's on the sticker on the thing. That doesn't surprise me at all. Yeah, not so much. Oh, this is interesting. It actually explicitly has a trial mode that it says will just shut down after 20 minutes once 30 days have expired, which I don't think was the case with Windows 7 retail, right? Like, I think you could run it kind of indefinitely without a CD key, but maybe I'm misremembering. I certainly don't remember it being this explicit about it, but yeah, I don't think it'll take me 30 days to demo this thing for you. Oh, it actually puts a little mark of shame on your desktop. Loser. Loser. You're a loser. You want a bottle? You want a big dirt ball? All right, well, there's Windows. Let's take a look at Device Manager, see if there's anything spicy in there. Curiously, there appear to be 2 HD audio devices. I wonder why. Oh, it's still got the HDMI interface built into the graphics controller, even though there's no actual HDMI interface on the device. Although I guess if they'd populated the DVI port, could that have worked? I don't know if you can run HDMI with audio over a DVI port. A thing I always wonder, in fact, about this sort of thing, we saw earlier that the board had a pattern for a DVI connector. If I were to just desolder the VGA plug and solder in a DVI plug, would that work? Would it start working? I have no idea. Are there missing parts? Or is it just like a normal graphics card where it just detects which port has something connected? Maybe we could take a look at the display properties and find out? I would probably need the driver installed. Well, with the drivers installed, it's not a whole lot clearer. All it says here for display options is digital display, LCD TV. And it's interesting that it says digital display because that's not part of the device identifier. If we look in the Windows panel, it says it's just LCD TV. So yeah, this is acting like that's a digital interface. So I'm not really sure what's going on here, but I'm super curious. See, I took a look at a dead graphics card I have, and this looks like the exact same pinout. This one has a DVI port on it, but right there, that looks like the pinout of the VGA connector we saw in there. And I remembered I've seen this before, graphics cards that are available in a VGA plus DVI config, but you can also get them in a dual VGA config, and this one will be that little tiny slim connector like we saw in there. You know what? I'm just going to try moving the plug over, and we'll see what happens. Obviously, there won't be room for the DVI connector on the back plane here, so I'll just have to take it right back out if I'm going to put this thing back together. But, I mean, what else am I going to do with it? It's only an i3, and that doesn't make it useless, but it doesn't make it terribly useful to me. And since it's not socketed, I can't upgrade or anything. So, yeah, if I break this thing in the process, I'm not going to cry over it. Oh, yeah, that looks like the exact same pinout to me. This is a Heiko desoldering gun, and it makes this process much easier. I usually add a little bit of fresh solder. It just helps things remelt. These ground pins could be trouble, but that looks like it cleaned out. There we go. It looks like the connector's intact and the pins aren't mangled, so I think I can move this over. There's that connector between the boards in case you're curious what it looked like. Looks like that. Alright, so I gotta be a lot more careful with this one. There's fewer pins to deal with. and they're simpler, and there's much smaller lugs for attaching it to the board. So I think I can get this out without too much trauma, but the pins are smaller, so let's hope for the best. All right, and with the application of an enormous amount of patience and an illicit dual iron technique that's been banned in 6 states, I was able to get this wafer-thin VGA port out of the thing, apparently intact. Did I overheat any traces? Did I rip out any vias? Hard to say. Let's just assume I did. Let's figure that this works worse than it once did and move on. So right off the bat, this is not going to fit directly because it doesn't have the same kind of attachments in the back for the shield, so I'll clip those off. The rest of the pins look compatible, although I'm a little uncertain whether these guys are going to fit through the retention holes on the board. Well, nothing to do but to do it. It is remarkably difficult to insert a connector with this many pins into the board all at once. I think they need to be straightened a little bit. It looks like, unfortunately, these retention clips here will not go through, so I'll have to remove those. That was the only problem. Just like that, it dropped straight in. Terrific! That was a bit more flux than I intended. All right, that's seated. Let's just get the rest in. Well, that's not one of my better soldering jobs, and my better ones are bad. But then my eyes aren't what they used to be, and they used to be shit. Nonetheless, the connector is in there, and there's metal on each of those pins, so this is in. Do we think this will work? Do I think this will work? Not really. What, do you want me to lie to you? I have no idea if the presence of this board is actually required for operation, but it does have the power button, so I guess I'll install it. We can't put the back plate back on due to the cutout for the VGA, but we do have to put this back in here in order to screw the heatsink down. But that's all we actually have to attach. This 4x3 display is the only convenient DVI monitor I have right now. A moment of truth approaches. The question, will it blend? Will it cook? Let's find out. Oops, should probably put that on DVI. Well, at least the motherboard ain't shorted out. But I'm not seeing much. And it did not work. It did not work. Now, the remaining question, are the analog pins hot, right? Maybe there's no digital interface enabled down there, but if the VGA interface and the DVI are sharing the same pins for the RGB HV lines, then it should work. I don't know if that's how that works. And I'm going to say no, that did not work. Great news, everyone. I broke it. Wait, hang on, the cable fell at the back of the monitor. So the VGA lines are hooked up. Boy, what a practical joke this thing is now, right? What if I just nibbled the rear case out a little bit to make room for the connector, put it all back together, just took it back to the store. Let somebody else buy it, try and figure out this this puzzle box I've created. I mean, just for kicks, there's nothing in here, I suppose, about choosing the display mode, right? Yeah, these seem to be the only graphics options, is like memory and frequency stuff. Just for kicks, let's boot up into Windows one last time and just see if we can adjust anything. All right, so obviously Windows is still working, but let's see if we plug in the DVI monitor. What if it detects it? Whoa, it's working! What? Why didn't it work during post? It's working! I didn't break it! All right, now surely this isn't the outcome anyone expected, right? I kind of suspected, I more than kind of suspected that this would work. I figured that probably, since the onboard graphics, they're built into the Intel chipset, there's really no reason not to bring out the VGA and the DVI. It all comes from the same place, if I recall correctly. I think the VGA is actually generated on the chipset, but the DVI is built in, an HDMI and DisplayPort and the whole 9 yards, if I remember correctly. So if you're making two different versions of the board, one with DVI, one with VGA, well, you're putting the VIAs in there for it anyway, right? So there's no extra parts required, I think, to drive the DVI. I don't think it requires any sort of like buffers or anything like that. I think it just drives directly off of the... You know what? I don't know that. That could be bullshit. I've never looked into this. The point is, I figured that probably everything that needed to be there was there, and it turns out that it is. So this is a utterly pointless mod, since I now can't put the back panel back on unless I chew it out with a chassis nibbler, but maybe I'll do that. I don't know. But I've always wanted to try this. Every time I see something that's got that combo pattern on there, I always wonder to myself, can you just do the swaparoo? Sadly, this card doesn't work. Otherwise, I would, complete the look by just taking the other connector and soldering it on there. But we can guess that that probably would work. Great job, everyone. That was a great way to cap off this video. I have no idea how to do any of that GPIO or Watchdog stuff or whatever that I was talking about. But even if I did, it took me a little bit longer than I intended to do all this. I started this video at like 9 p.m. So I'm going to shuffle off to bed now, but thank you all so much for watching. This was a blast for me, especially because I didn't break it, and I hope you had fun too. If you did, and you're not already a subscriber, then consider subscribing to my channel. I'd appreciate that. And let me know you like this sort of thing. I'll make more of it, as if I'm not already making a ton of these. There's a ton of these in the pipeline. If you like this, remember to subscribe if you want to see future episodes. But if you really like this, then consider supporting me on Patreon, like these people are doing, because they're the only reason that I can afford to go out and just pick up stuff like this and then just break it, or at least try to. These things are just sort of random items that pop up in my peripheral vision, and I have to grab them when they come by. So I'm really glad that my patrons are making it possible for me to do that, giving me a budget for these things, not to mention groceries and gas in my car and rent and the whole 9 yards. So I'm incredibly grateful to all of them, and to everybody else, thanks for watching.